The HIV/AIDS pandemic is one of the defining medical challenges of our time. But to really truly understand it, we have to rewind the clock. We're talking millions of years, back to a family of viruses locked in this incredible evolutionary dance with primates. And just to get a sense of the scale here, the HIV pandemic has affected an estimated 40 million people around the globe. It's a staggering number. And while HIV is a pretty new virus for us, its ancestor has been a constant companion for some of our closest relatives for a very, very long time. So, how did it get to humans? Well, it happened through something called zoonotic transmission. It's a fancy term that just means a disease jumped from an animal to a person. Scientists have traced HIV-1 back to chimps and HIV-2 to a monkey called the Sooty Mangabey. In both cases, a virus they carry, called SIV, that's simian immunodeficiency virus, crossed over to us and became HIV. And that's where our mystery really begins.
Okay, so this right here is the central puzzle. It's wild. In humans, a high level of HIV in the blood, what we call a high viral load, it leads to the immune system just collapsing, and eventually to AIDS. But get this, in their natural monkey hosts, SIV often replicates to insanely high levels, yet the monkeys just live long, healthy lives. We're talking about the same amount of virus, but with completely different outcomes.
So that's the big question, isn't it? What is the difference? Why is this virus so catastrophic for us, but basically a harmless passenger in its original hosts? What's their secret? The answer, it turns out, is buried in a deep story of evolution and adaptation.
So let's start with the most obvious question, the one we're probably all thinking. Let's dig into what we can call the primate paradox.
It's a pretty intuitive idea, right? Maybe the monkey version of the virus, SIV, is just, weaker, a less aggressive strain. It kind of makes sense that it would be less harmful. But as it turns out, the data tells a completely different story.
Yeah, this chart just says it all. When scientists actually measure the amount of virus in the blood, they find that these healthy, SIV-infected monkeys often have viral loads just as high, sometimes even higher, than human patients who are getting really sick from AIDS. So that weaker virus theory, it's out. These monkeys are absolutely teeming with virus.
And here's where it gets even more puzzling. For us humans, and for other primates who are not the natural hosts, the rule is simple. More virus equals getting sick faster. It's a clear-cut relationship. But in the natural hosts, like the Sooty Mangabeys or African green monkeys, that rule is completely broken. There's just no connection between the amount of virus and whether or not they get sick. It's bizarre.
So this is the kicker. Despite being packed with virus, the monkeys' immune systems aren't collapsing, not at all. This chart shows the count of these super important immune cells called CD4 plus T cells. In a human with progressing AIDS, this number just plummets. But in a healthy monkey with tons of SIV, it stays totally normal. So if it's not the virus, what is it?
Well, this brings us to the real culprit. It's not about the virus itself. It's all about how the host's body reacts to it. This is a tale of two completely different immune system strategies.
Just take a look at this comparison. When HIV gets into our bodies, our immune system goes into what's called chronic hyperactivation. You can think of it like a fire engine with its siren blaring constantly, day and night, until it just burns itself out. But in the monkey, the immune system sounds a brief alarm, handles the immediate problem, and then it just calms down and returns to normal, even with the virus still hanging around. It controls the damage from its own response.
We can actually see this happening at the molecular level. In African green monkeys, for example, an SIV infection triggers this rapid flood of anti-inflammatory signals, like TGF-beta and IL-10. These are basically molecules that tell the immune system, okay, hey, stand down, no need to panic here. And that prevents the chronic, damaging inflammation that causes so much trouble for us.
So how in the world did these monkeys develop such a sophisticated, chill response? Well, it wasn't by chance. This was something earned over a massive, massive time scale.
Yeah, the lack of disease in these monkeys is the result of what's called coevolution. You can think of it as a truce, one that was negotiated over thousands upon thousands of generations. The virus gets to replicate and the host gets to live a normal life, all because the host's immune system learned not to overreact.
So we can basically break down their survival strategy into three key adaptations. First, like we've been saying, way less immune activation. No panic. Second, they literally have fewer vulnerable target cells for the virus to infect, especially in the gut. These are cells that have a specific doorway the virus uses, called a CCR5 receptor. Fewer doors, fewer problems. And third, their bodies are just way better at regenerating any immune cells they might lose, so they always maintain a perfect balance.
Now, this ancient evolutionary story isn't just some fascinating piece of biology. It actually holds some really profound lessons for our modern fight against HIV.
This quote from the researchers just sums it up perfectly. The monkeys achieved disease resistance not by destroying the virus, but by learning to live with it peacefully. They tolerate the infection without suffering the consequences. It's a complete paradigm shift.
And this is why all of this really matters. For decades, our approach to HIV has been focused almost entirely on attacking the virus itself. But the monkeys show us another way. Maybe, just maybe, the future of HIV treatment involves not just antiviral drugs, but also therapies that calm our own overactive immune systems, therapies that could transform a deadly infection into a manageable chronic one.
So it leaves us with this fascinating final thought. We have spent so long trying to conquer this virus, to win a war against it. But maybe the ultimate lesson from this 40-million-year-old story is that the best way to win is to finally learn how to make peace.